Great. Well, good afternoon, everyone. Thank you so much for joining us. My name is Miharu Morimoto. I am a senior associate at Ziegler Architects, and as a board member of Building Enclosure Council of Baltimore, I will be moderating today's presentation, Foundations of Fenestration on Historic Buildings. Before we begin, I do want to go over some housekeeping rules. I think we are pretty comfortable at this point with some of these rules by now, but just to go over, this session is recorded and it will be shared on AIA's YouTube page. And then during this presentation, everyone will be muted, but please feel free to use the chat function to ask any question. And then at the end of the presentation, there will be an opportunity to do a Q&A. So if you do have any questions to kind of follow up, you will be able to unmute and have a more of a fluid dialogue with the presenters. Today's session is an AIA accredited presentation, and there was a section to include your AIA number when you're registered. But if you missed it, like I did, you can still send it to me. I will leave my email address in the chat box, so you can just send me your AIA number and your name. That would be great. And AIA Baltimore has really provided a tremendous amount of support for setting up this event today. So I just wanted to take a moment to thank you again for helping us. So Building Enclosure Council is a subcommittee within AIA Baltimore, and with support and collaboration with the industry organizations and professionals from a wide range of disciplines. Our mission is to establish a forum for sharing ideas and experiences on building design and science, which are constantly evolving. And we typically plan about 4 to 5 events a year, and we do have a few more exciting things coming up. So take a look at our website, or you could also join our mailing list so that we can keep you up to date with our future events. Also, if anyone is interested in helping out, please reach out to us as well. So today's presenters are from the Baltimore office of the Building Envelope Consultants and Scientists, and our discussion to do this sort of like something together started back in I think 2019, and it took a bit of patience and persistence from all those involved, but we are really glad that we are finally able to share the depths of knowledge that these guys have on building envelopes, particularly as we face the reality of these existing and historic buildings, which we have a lot of in Baltimore. And with that, I am really thrilled to introduce our friends from BECS. We have KJ Rogers, Mark Howell, and John Burnett, who is a senior project manager who will be doing the most of the presentation today. Thank you so much again for joining us today. I will let you, John, take over from here.
Thank you very much. So this is our presentations for fundamentals of fenestrations. We'll go through some basics here at the beginning. Our learning objectives here, leak investigations, how surrounding substrates may contribute to the leaks. I need to change one thing real fast. Sorry, bear with me real quick. All right. Factors to consider when evaluating historic fenestrations, the use of mock-ups and prototypes, understanding the different testing methods, and evaluating the risk and cost factors of renewal versus replacement programs. This is our copyright page. Mark Howell is on the call. He typically gives this presentation, but Mark is traveling, so he's going to be kind of in and out. But Mark,
hey guys.
Yep, there's Mark.
Here in beautiful Pittsburgh, Pennsylvania. You can't beat it.
So Mark's been in the building envelope field for quite some time. I met Mark back at Structural Preservations when it was called Structural Preservations. A lot of restoration projects that we worked through together. And then he kind of joined the consultant side. I went to the actual Windows side. So I was a contractor for a number of years working with Windows, and me and Mark have kind of join back up on the consulting side here at BECS. So a little disclaimer here, windows and fenestrations is a huge topic. This is probably going to take, a little over an hour, but as far as talking about it, we could fill up 4 hours time slot if we wanted to. We just can't cover everything. So this is going to be kind of a 20,000 feet elevation view versus, kind of getting up close. You're happy to answer questions at the end, but we'll kind of scratch the surface of a lot of the topics. What are fenestrations? Fenestration refers to design, construction, and presence of openings in a building. So, other words, it's a hole in your walls for your building. Types of fenestrations: you have windows, curtain walls, storefronts, historic windows. Other openings that aren't quite as common, but you see them a lot of times: skylights, louvers, vents, sliding doors, PTAC units. A lot of these things can be made of different materials: aluminum, vinyl, fiberglass. Wood is typically your historic, steel, and they have composites that are coming out now. Get into windows. So there's primarily 3 types of windows: your punched, mulled, and continuous ribbon. Your punch window can be a horizontal slider, a casement, an awning, a hopper, a hung, a fixed. Mulled assemblies are just meaning that there's 2 windows put together, kind of the picture the picture on the slide. We'll get into continuous in another slide after this. New construction versus replacement. They get installed differently. And again, there's different types of materials that can be used depending on your window and what the building requirements are. Punch and ribbon windows. Punch window is basically what it means. It's a punched hole in the building envelope, and it's typically a singular window, or it could be a mulled assembly. A ribbon window is a series of windows set side by side to create a horizontal band, typically very popular in office space. Here's an example of a mulled window assembly. The one on the left is what we would consider a twin that's been mulled together, and then the one on the right would be a twin operable with a fixed on top. These can come in a lot of different arrangements depending on what the building needs. Our types of materials: your wood window up top. The aluminum clad is basically a wood window with aluminum cladding on the outside. Aluminum windows typically used in higher, taller buildings because of the performance ratings. Vinyl is a highly efficient window, but typically doesn't go as high as an aluminum window would. Fiberglasses and the composite are kind of the in-betweens. And then you have your steel windows. Curtain wall and storefronts. Basically the difference between your curtain wall and storefront. Curtain walls are non-load bearing and they hang from the floor slabs. Curtain wall lineals can be up to 25 feet or higher and typically span multiple floors and is usually front glaze. Also, curtain walls are self-draining. That means that each individual window will have a weep system, which you'll see in the next slide, at a horizontal.
This is an important topic. I know that it doesn't look like historic windows to you guys, but honestly, we run into a lot of issues trying to define the difference between storefront windows and curtain walls. And as we get into talk about historic structures, as everybody knows, there's plenty of buildings that are mid-century buildings now that are historically significant. So the terminology of curtain walls are going to have to make a great leap, from what we see today on existing structures to what they tried back in the 20s and 30s and 40s and 50s. So I think it's really important to understand how a curtain wall manages a water from a basis of understanding, so that as you look at more historic kind of curtain walls, you really have to dial back your technology and understand what was the materials and what was their thought process for a basis of design on a 50-year-old curtain wall, and what materials were used. Especially, I have a Bechalon used corrugated wire reinforced glass, which was ridiculous. So it's going to make things a lot complicated when we're dealing with historic curtain walls, even more than traditional punch and ribbon windows.
So your storefronts are an assembly of commercial entrance systems and windows designed for high use and strength. Typical storefront does not go higher than 10 feet. Once you go higher than 10, you're stepping up either the depth of the system, or you're moving to a curtain wall system. Storefront is typically center glazed and not self-draining, which means that all the water is going to run down to the bottom and then come out of a sill starter. It's not individually weaved as a curtain wall is.
I think John would agree with this. Part of the challenge that we're seeing in the Baltimore region, and it's probably in every region, is that we do see, for some reason, architects designing structures that are 6-7 stories tall, maybe even 4 or 5 stories tall. And because storefront windows are cheaper, they wind up being the storefront windows that are built as ribbon windows rather than curtain walls. So I don't know, John, if you've seen a lot of that kind of situation where we have leaks in 5 and 6 floors, and it winds up being somebody tried to get by with the storefront.
Yeah, and a storefront is okay in like a punched opening, but when you start stacking it up amongst itself, it's not designed. You have to break it every once in a while. And again, a 10 foot is kind of the rule of thumb, that storefront itself won't go higher than a 10-foot section. So they can be built 2 ways. Curtain walls and storefronts, they can either be stick built or unitized systems. Both have their pros and cons. I think the next slides get into some of that. So your stick-built system generally is cheaper. It's a shorter lead time because they can buy stock material and fabricate it on site. The install time is going to take longer because they're doing all of this in the field. And then your on-site storage needs, you're going to have long lengths of materials that are on site. And then being that it's in a field fabrication, then you're more susceptible to leaks because it's not in a controlled environment as unitized systems would be.
And when we're actually doing peer reviews for new construction projects, a lot of time if we know the intent is to do a stick built, we're really trying to encourage people to have a much greater presence of us on site to do the testing, just because of all the things in the field that can come up and modifications, and maybe things don't work the way they're supposed to be. Biggest thing on a building like this that we've recently worked on, John has painfully spent the last year plus of his life on, was a more contemporary building, however, that had terrible plumb and level conditions of the concrete frame, which threw the stick frame, and actually that was, I think, even a unitized system, way out of whack, where you had all kinds of construction deficiencies because of the concrete frame. So just remember, when you are going to specify and deliver a stick frame or stick built system, definitely put some more time and energy into the field inspection and field testing.
I agree. The unitized systems, these are going to be made in a factory and then pre-glazed, and then they'll be stood up in place. They're faster installations, typically better water performance because you're getting factory installed systems, but your lead time is going to be longer because they're doing more for you at the plant. And sometimes they can be more expensive.
And that's where this will be the last time I chime in, John, until we get to historic ones. But it's important because we have a lot of architects on the phone call. If you pick a unitized system, you better think through your process of how you're actually cladding your building, because you lose all value of a unitized system if you make a cool building with all kinds of ins and outs and inability to use a consistent unitized system. So if you're married to a unitized system, it's absolutely going to change your kind of concept, your design concept, because if you're going to want that savings, you're going to want a different looking building. I hope that makes sense. John, does that make sense?
Yeah, and the thought of how do you get some of this stuff up there? These are going to be big, large pieces that are heavy. So the stick built, the pieces are smaller. And they can build smaller things and kind of put them into place and then handle the glass individually. So just things to consider. Kind of mentioned this earlier. Your stormwater management system, or your storefront water management system, is directed to a subsill at the bottom of the system. The water is, let in and then it's let out at the bottom through a weep hole at the bottom of the system itself. The curtain wall, however, is kind of mini weep systems within the glazing pocket that allow the water to come out at each horizontal. It doesn't have to go all the way to the bottom like a storefront system does. So you see the picture on the right, there is that system sits in a subsill, and a lot of times you see people caulking over that where the arrow is, where it says do not seal. that is the exit for the water that gets into the subsill. I've seen that caulked many times, and people wonder why their system is leaking, and it's because it's not allowed to work. Some of your pros and cons of face sealing existing windows. A lot of windows are set up to be to take in water and then let water out. If you start face sealing it, you almost have to be perfect in order to keep all of the water out, because if you introduce any of it, then you've probably sealed an area that was meant to weep. Kind of that bottom arrow on the right there, same deal. It's that bottom section that is made to weep, and it's not allowed. So any water that gets in the system becomes trapped, and it will probably migrate to the inside. And you can see some of the improper ceilings can lead to more damage, lintels and some areas within the cavity wall that could rust out or get to your framing.
Yeah, this was actually the same job, John. So what's interesting here is there isn't 100%, right? So when we say we're face sealing something, it's no joke. We're face sealing everything. And if you look at those photos, it was an issue where they didn't face seal 100% of the joints, and they wound up with some water in the masonry opening because all the fasteners were corroded.
Exactly. It has to be perfect.
And this begins our discussion about existing buildings, maybe not historic, but at least existing buildings. You need a plan. You just can't send a caulker over the edge with a caulk tube and start caulking things. We talked about this before we got on the call. With historic structures, I can't tell you how often bad maintenance has made historic structures age hundreds of years rather than just leaving it alone. It's really, and this is another great example. This building probably would have had, a little bit of leaks here and there, but now you got windows that are loose. Now you're replacing windows because you didn't know what you're doing.
Exactly. So some of our other fenestrations, skylights and slope glazings. So when we talk about that, we're not talking about the ones that are in your house, like shown in the picture here, the ones that, are kind of put into a A-frame roof. Most of those are covered under the North American Fenestration standards for testing. We're talking about more of this type of slope glazing, which would be kind of like the greenhouse type roofs. And as you can see in the pictures, a lot of dining areas, rooftops. They're supporting members, rafter spanning from sill to ridge, crossbars between the rafters, pressure bars that clamp the edges of the glass to the rafters. The infill panels are typically glass. They don't have to be. They could be fiberglass sheets or fiberglass sandwich panels. Louvers and vents, and you can see in the building here, at the top of that Care First building there's a octagon type louver up there that we're testing on the right hand side, and it's for airflow, exhaust in the building. They're typically horizontal slats that are angled that'll let a little bit of light in and air, but it'll keep the rain out.
Yeah, so this was also an issue of plenum space. So louvers and plenum space, we're going to talk about PTACs too, which is another one of my pet peeves. But with louvers, you need a waterproof plenum space. And this was a great example, about 25 foot tall by 25 foot wide louver, 4 of them on the entire building, and no pan flashing, and the plenum wasn't waterproof. They would actually have light snow blow in and sit on the plenum floor. And just so happened to be right below where this was the IT room and the server room for a very well-known insurance company. So the thought process of drawing a louver and then not really following through with the mechanical contractor and the rest and the base building contractor to make sure these louvers need to be looked at as a system, not just the louver, but the entire plenum space, and what's the activity going to happen, and how do you actually keep water out of the building at these things?
Right. Yep. And Mark kind of touched on that with the second bullet there. It's going to allow some free air to come in, but you can allow water, snow, other items that will get through those louvers as well. Exit doors, these have to have special consideration. Doors require perimeter flashing, prevent water infiltration. That's already migrated to the interior. Thresholds, drainage systems, channel water, and weeps in a sill to evacuate channel water. A lot of times, these sills are low-rise sills to meet fair housing and ADA. And sometimes that won't give you a very good water rating or any at all. So it's something to consider that some of these doors, when they get higher up on buildings, that they need overhangs and taller sills.
So John, would you ever recommend putting a slope glazing system above a door, 8 stories in the air?
Absolutely not. You know, and it's funny, Mark brings that up because we're working on that building right now. And basically you have the 10th story unprotected terrace door with 20 feet of slope glazing up above. So you have to consider all the water that the door is now being asked to handle, and it's its own water plus all of the water from the glass above. So in your design, you know, considering how much you're going to add to fenestrations below if you don't have a break in the system. The PTAC, Mark mentioned this earlier. This is very popular. These are typically through walls. A lot of times they're a combination with the windows. Sometimes it's built into the frame or it's connected to the frame. When they're tied to the window, it's a difficult juncture between the two in order to get these waterproofed. So that's really important for your through wall flashings, your sill pans, and then how does the PTAC drain? Does it drain out of the front? Does it, you know, get routed to a drain line? A lot of considerations when PTACs are installed into buildings.
And just to be clear, the picture on the top right, someone felt that it would be a great idea to use the PTAC sleeve itself to be a structural component to hold up the brick. So I'm telling you, man, PTAC units are used and abused. Most of them always leak. We've seen projects that we've gotten on where they've spent millions of dollars on exterior facade restoration and for some reason won't just replace all the PTAC unit sleeves. So if you have existing buildings and you have an existing PTAC unit, you really have to understand if this is a contributor to any leaks. They usually are, to be honest with you. They're just kind of something people don't want to get into because it crosses that threshold between facade guys and mechanical guys, which for some reason, you know, nobody talks to each other. And they'll actually, I've been on projects where they actually replace the guts of the PTAC unit, but leave the sleeve in place, and the sleeves leak. So it's just be aware of these things. They are definitely like built-in leaks when you see them everywhere.
Absolutely. Lots of problems. Historic considerations. Considerations of modern versus historic. Historic buildings have a different meaning in practice that you may imagine. Historic is no longer mass masonry walls and wrought iron window frames. It's 2021, so buildings constructed in 1971 or earlier could be considered historic. Mark, you can probably elaborate on the, actually it's this, the 50 years, yeah, and this is pretty interesting. The historic field house, High Field House, built in 1964, is a historic building in Baltimore. It was actually 47 years old when it was deemed historic, but it has historic relevance. Hence, you'll have to preserve the historic significance of it.
This was an interesting project because we got called out for this project because according to their reserve study, they had to replace their windows. Why? Because the reserve study said so. Did they have any leaks? No, but they had a reserve study. So what we wound up trying to help them do is identify the existing performance of these windows, which are historic, and identify if there's really a purpose at this point in time to replace the windows, which through, I think the next slide, I'm not sure if it has that, John, it has some testing photos where we did air and water testing and we ran some thermal numbers. And we were able to identify that these windows are in good shape. I'm gonna say they're fair to good. I mean, they're old, right? They're much older than most windows that we see. But there's no reason at the moment to replace these windows. We did find some water leaks that was easily taken care of by adding a new gasket, a new bulb around the operable window, and the water leaks went away. It also vastly improved the air leakage testing. So testing, I can't say enough about it when it comes to historic windows. If you're making judgment calls on what to do with windows and you've never actually put a chamber on, or you've never put a blower door in and tested the window, I don't know what you're basing your decision on. I really don't. Because you don't know if the thing's leaking in the first place. People just replace windows because they're old, which again, in this particular building, thank goodness, someone pressed the brakes because it has this historic significance, and they got us in there, and we were actually able to identify what we needed to do. But with big development projects, with big developers, I don't even think they think twice about it. It's a money thing. They just replace the windows. And at that point in time, which we're going to talk more about, is, are you really doing any justice by doing that? Or are you just doing it because it's easy? You really don't understand how the windows are performing. You don't understand how you can potentially extend their useful life. And I feel like SHPOs and our preservation community has kind of given the leverage to the development companies, where the development companies just can basically fib numbers up and explain their way out of preserving windows, because they really don't know what they're doing in most cases. So when you get, especially metal windows, I'll tell you, metal window frames are so robust, so hardy, that if you don't have a lot of corrosion and significant corrosion on it, there's no way you can't potentially even reglaze and get these things operable and perform to a certain level. I also think codes don't help these as well, because they try to meet current codes with older windows. And the one job that we did years ago, we were able to kind of show how much improvement we can get out of a historic window just by putting new glazing system and new weather stripping in place and a storm window on the inside. So I just don't think, I don't think people have the time. And I think sometimes people just don't have the patience or cost understanding to really understand how to preserve anything historic when it comes to windows, let it be punch windows like this, or especially a curtain wall system.
Sorry, I'm breaking my own rule by kind of speaking up right now, but this is really fascinating. You know, I mean, there are so many windows, and I'd like to know, you know, when you guys were brought on board to do the testing, was it for the water leak or for the air?
You know, this one in particular, we literally brought out because the condominium association, who has a bunch of architects on, which is awesome, pumped the brakes as soon as they read the reserve study and followed the reserve study, replaced the windows. They all went, do we have to? You know, why do we have to? Just because the reserve study says we have to, because they're over 50 years old. Why? So that was their triggering question for us, was give us some reason why we need to, or tell us some reason why we can extend the useful life of these. So unfortunately, it wasn't for leaks or for air. We used those tests to determine that they had life in these windows, you know?
And so when you did start to kind of look further into these windows, I mean, there are a lot of them. So you didn't test every single one of them, but, you know, what is the type of, what is there like a percentage that you do like a sampling of to kind of get a sense of, you know, what's really happening, you know, overall, like generally, or do you kind of, you know, investigate each individual window units?
I don't remember how many we ran the test for. I know we walked through a bunch of units to compare and contrast the conditions from the inside to see if we've seen any major differences. I don't remember how many windows we honestly tested. It's a great question, because obviously that's tied to money, right? So you know, I think there's that fine line between they want to know, they want to have an answer, but they also don't want to spend, you know, $200,000 on testing. So on a project like this, really what we would try to do is determine if we see an elevation weathering greater than the other elevation. That could be, and again, we did a binocular survey, and then we walked around from the inside and looked at windows. And you know, that's how we kind of judge the quantity of windows. I'm not saying it's completely subjective, but there's a lot of it there, right? You have to have an understanding and a feeling for how the windows are aging, and if there's a common theme to worry about or not. But access is always an issue, especially, that's what I'm saying about some of these bigger buildings, right? This is no longer two, 3-story mass masonry wall, right? This is a multi-story building. We do have the ability to do industrial rope access, which is basically jumping off the buildings. This particular client wasn't interested in doing that, but we could have, in this particular circumstance, maybe jumped off a couple, 2-3 areas and seen from the exterior what we saw as well. But in lieu of that, we used the binocular survey to really gather it. And honestly, they weren't reporting many leaks or issues. So it was a pretty healthy look at, you know?
That's interesting. Thank you.
One note, you know, on here, some of the old repairs on a building that were performed on a building prior to becoming a historic structure may be required to be reserved, as the repairs can be considered historic importance. So a lot of times, sometimes when you have to go back with a historic window, they want the original look of the building and not repairs. So it could actually be a repaired window that you'd be restoring and not the original look. Just thought it was a fact. tax credits for rehabilitation and restoration. This is Mark's cup of tea.
Yeah, it's tough, man, because I'm telling you that, you know, by the time you get to a part 2 and you submit your part 2 of what you're going to do, you better have a pretty darn good idea of what kind of restoration work you're going to do to these windows to preserve them. And it's really difficult to get that number that early on. So my feeling is there's a lot of budget numbers. There's a lot of ROMs. There's a lot of, who did you call? Where'd you get the number from? Because by the time you submit that part 2 and you get approval, you're now married to do whatever that work you said you're going to do. And during the initial part 1, the sooner you can get on these windows and do some baseline testing, gather that information, and really begin to look at this holistically, the better. The challenge is that costs money. It costs money for access. It costs money for testing. And a lot of times these preliminary steps just are difficult to get people to buy into because, you know, at this point in time, you just have a concept drawing. You don't even have drawings and plans put together yet. So I think getting anybody involved, us, whoever it may be involved earlier, that can balance, and we talked about this before we jumped on the call, this entire thing about fenestrations is a balance between understanding cost, technology, and expectations. That's a mean mix of stuff, man. And I just think you need different people to look at these. You call window guys, you get one opinion. You get, especially a new window manufacturer. What do you think a new window manufacturer is going to tell you? Of course, replace the windows. So you really need the right people that are going to holistically look at this. And again, I don't care if it's us, whoever it is, the windows deserve the attention and the right person to really determine whether, you know, there's a real need for a replacement program, something that invasive, or can there be a repair program? And that's really where these tax credits get complicated, because a lot of times you're making decisions based on financial models, and you're only in a part 2, and you haven't even got that approved yet. You're submitting that, right? So I'm definitely empathetic to the cause. I just think that it's important to understand the existing performance of the windows before you jump too deep. You know, there's plenty of buildings, believe me, I walked up to that are historic buildings to go, boom, they got to go. I get it. There is a lot of that. But I think as we approach buildings that are younger buildings and not traditional historic, again, mid-century buildings, it's not going to be, look at the old wood windows that are rotted. We need to replace them. It's going to be more complicated.
Agreed. So tax credits following the NPS preservation briefs.
These are just important to know they're there. I'm telling you, there's so many developers I talk to that I say, hey, man, are you going to follow the preservation briefs? And they look at you and they tilt their head. And I swear they've never even read one of these. So it's so important to understand what a great resource these are. We're going to talk about in the preservation brief, it walks you right through the kind of repairs that need to be done. A lot of this information we're sharing with you guys, we are not some brilliant guys who made these things up. These are resources that are out there. You just need the right people that champion the cause and walk through the process. And the next slide kind of shows that.
Right. So your historic window, salvage, replace, repair, or replace. And you got to ask yourself some questions. Are they significant to the building? Are they original? Do they reflect the original design intent for the building? Do they reflect the period or regional styles of building practices? Do they reflect changes to the building resulting from major periods or events? Examples of exceptional craftsmanship or design. If determined that they are significant, begin to plan the appropriate treatment process. And the historic windows can be made to be energy efficient, with upgraded glass packages, weather seals, more of repair items versus replace items. Sustainability, conservation of embodied energy, reduction of environmental costs, economic benefits, ease of maintenance, long-term performance. New can be 2 to 10, historic can be 60 to 100.
This is one of those I wish I could get the hands raised on who has seen this document before. Walter Sedovec does a great job here of pushing back on all the new aluminum window manufacturers who love to tell you how greatly performing their windows are going to do, but doesn't explain to you the embodied energy it takes to make metal and glass. That's kind of ridiculous, but this is a great article. Anybody who's interested in getting it, please let us know. We'll send it over to you. I think it really does help put people in their position when you hear about, let's just replace the window. and we'll get all this great performance, and it's, you know, it's much more green. You know, that's what you'll hear. But thank you. But I really do think if you read Walter's article, he really does help you understand, you know, what does it cost, or what does it cost energy-wise to create new glass, create new metal. So, you know, I'm not going to get into the science here, but I think it's a great article if you guys do historic wood window work or historic window work overall. This is definitely stuff you should have in your back pocket from a knowledge basis when you start to talk to, especially contractors, right? Because that contractors and window manufacturers, they're the two big dogs here in the fight about what do we do with these existing structures. It's kind of like asking a roofer if they think they need a new roof, right? Well, of course they're going to tell you that. You really got to be careful with how you do that. Walter Sotovic gets into the actually energy model of it and makes you understand how you can actually be more, you know, green, more efficient, if you know, when it comes to embodied energy and the carbon footprint, if you preserve those existing windows.
Agreed. And, you know, and Mark kind of touched on this, you know, the manufacturers. One thing to note, you know, low U values are for center of glass and not the sash or the average of the entire unit. You really want to look for the NFRC for the whole window performance. And this will give it, you know, this is considering what the frame is made of plus the center of glass, kind of gives you an overall U value. And then you have a replacement payback worksheet. You know, you have a payback for a window replacement, you know, could take 100 years for the energy savings that you may be promised. So the process of evaluating fenestrations. You want to start with an investigation, you know, assess the existing conditions, some field testing, understand the goals. The design, develop the drawings and details, a great project manual, and prototypes. Bidding, select the right contractor for the job, ensuring bids are apple to apples. Construction administration, approving a mock-up and a contractor submittals. I think these are critical in window replacements so that you know what you're buying. Quality assurance program, periodic site visits, verification, and then testing, integrity testing to make sure that the install is going as planned. The assessment of fenestrations, roofs, walls, mechanical, and windows. Is it really the window? Is it the sealants, the weeps, glazing pocket, cladding, air barrier trim, improper repairs? There's a lot of finger pointing when it comes to facades versus windows. Window guys point at facades, facade guys point at windows when you have a leak. So it's getting down to the root cause of where that leak's coming from.
Yeah, and like I said, once we get into more of these mid-century modern buildings themselves, that means the cladding systems, and when I say simple, they're, you know, historic mass masonry walls are not simple, but the use of different materials during mid-century and you know, there's a lot of people being innovative and creative, and the wall assemblies are not going to be as maybe cut and dry as historic mass masonry walls when you get into these more contemporary or mid-century modern buildings. I just think it's very important to understand that if it's Brulist architecture with concrete frames, okay, that's easy. But if you get these different cladding systems and wall assemblies, it's going to be very important to identify how you address your window opening in all these multitude of cladding systems that were through the 30s and 60s, you know?
Right. You know, and it's kind of the issue. Where's the drainage? You know, if water has a choice, it's going to go straight down, but it's going to find the path of least resistance. Flashings in wall cavities. You know, they break these at floor lines just so that you kind of can limit where a leak may be.
Yeah,
go ahead.
I also think that, you know, in the 40s and 50s, we did these walls that were kind of composite walls that kind of had a collar joint, and it wasn't really a true cavity wall yet. You know, it was kind of a drainage plane. There's a lot of wall knowledge that you have to attain to be able to just do you know, any sort of a window upgrade, and it's not going to be as easy as we think on some of these more complicated buildings.
Agreed. Documentation and quantification, a visual survey, development of a restoration window schedule. Each part of the window is called out with documentation and its condition. You can see from the survey sheet on the right there. You need a qualified person that knows windows. You'll want to point out the window location, condition of the paint, condition of the frame, condition of the sash, any glazing problems, anything wrong with the hardware, and then the overall condition of the window itself.
I think that one page, and we'll get into this because really that survey allows you to classify these things as class 1, 2, or 3. The challenge that we usually have is getting someone to do that survey or having someone to pay for that survey, because it is cost, and you really need access and cost. And again, it drives this thing where if you can get the survey and really understand the condition of all the windows and group them into these 1, 2, and 3s, you can really then begin to put together a process of repairs. But if you're globally just walking around and looking at them and you really haven't done any sort of a survey to create a window schedule, I just feel like you're starting to guess per opening what the repairs might be. And I think that's when things get to be a slippery slope.
Yeah, like Mark had mentioned, there's 3 classifications. Class 1 is your routine maintenance. So there's some degree of interior and exterior paint removal. Class 2 is your stabilization, remove the sash, paint, any minor repairs. And then class 3 would be splices and parts replacement, any rotten areas of sashes or frames that they can splice in new material and restore the original product. Change the basis of design and considerations. Is it for aesthetics, a solution to water leakage, water management outside in, moisture path inside out, windows, weeps, and pan flashings? Systematic approach to identifying and solving moisture problems. First you want to gather the history of the problem. That's interviewing maintenance owners, renters, management, anything that they can kind of lead you to where these leaks are coming from and how often and the frequency and what makes it. Is it a 10-minute rain? Is it 2-hour rain? So gathering the history of the problem. Understand the design. Search for the leak path. We're going to get into all these on the next couple slides. Perform proper testing. Discover the root cause and determine the solution approach. So this is you're gathering the problem. Your maintenance history. How long has the problem been there? Is it heavy rain? Is it wind? Does the wind come from a particular direction? Does it happen during winter, summer? How cold is it outside? How hot is it outside? Is it at the beginning of a rainstorm? Does it take a while for it to show up? All these things kind of lead you to a direction of solving the moisture problem. And then understanding the design. Look at the drawings. Look at the drawings to determine the type of construction and how did they plan on handling the moisture that got into the system. A site plan, building orientation, what side faces which direction, does it get more weather than others? Identify where the barrier or water management system is located, the type of material that's used, and the layering approach. Look for a leak path. Is it really the fenestration? I mentioned this earlier. When you talk to a window guy, he's going to point to the facade. When you talk to a facade guy, he's going to point to the window. So look for obvious defects. This is cracks, failures in sealant, effervescence, rust stains, interior staining, wet materials. Identify weep areas for managed systems. All of these kind of lead you to where the water is coming from. Is it getting in at the window, through the window, above the window, next to the window? So just kind of the obvious areas, and do some destructive testing. Open up a small hole on the inside so you can kind of see if the water's coming in next to the window or through the window. Look at terminations, joints, changes in plane, parapet walls, penetrations, anything that could be a weak point in the facade that would contribute to an interior leak. Our testing. Types of tests and when to use them. So we have 3 types of tests. We have a lab test, testing products prior to installation to ensure specifications are met. This is done in a lab. You send a sample to the lab. They run the performance at lab values for the performance of the window. On-site quality assurance, perform newly installed components to verify design criteria. Typically, the field test is a lesser test than a lab because you're working with a field condition versus a lab condition. And forensics, find the problem. Tests are performed looking for causes of failure. So we're trying to recreate the leak, and then we'll pinpoint a fix. The AIA 501-1, this is dynamic water testing. It's a standard test method for water penetration of windows, curtain walls, and doors using dynamic pressure. Water penetration testing consists of utilizing a portable wind generator equipped with a water system. This is for on-site use. Typically, a forklift is required to position the machine at elevations above the ground level. A forklift is commonly available and has a reach up to about 45 feet. Wind speeds can get up to 110. Water tests are typically run between 50 and 75 miles per hour per industry standards. Tests are typically run for 15 minutes per test area and have a coverage of about a 10 by 10. Typically, you can get through about 10 of these on a job site as long as you have access and site coordination. The AIA 501-2, this is the handheld water nozzle testing, quality assurance and diagnostic water leakage field check of installed storefronts, curtain walls, and slope glazing systems. This is a handheld water nozzle consisting of applying water using a handheld spray assembly employing a type B 0.030 nozzle, pressure gauge, control valve, and just your typical 3/4 inch garden hose. The water flow to the nozzle is adjusted to produce about 30 to 35 PSI at the nozzle. The water will be directed at the joint under test, perpendicular to the face of the specimen. The nozzle will be moved slowly back and forth above the joint at a distance of about a foot for a period of 5 minutes for each 5-foot length of joint. An observer on the inside will check for the water leakage. You can usually get through about 350 linear feet of joints per day, again, depending on access and site coordination. The ASTM E1105 is static chamber water testing, standard test method for field determination of water penetration of installed exterior windows, skylights, doors, and curtain walls by uniform and cyclic static air pressure difference. Water penetration test performed using a chamber. It's attached to the inside, sealed to the interior extents of the test area. A uniform calibrated spray rack is utilized on the exterior face of the test area. Controlled blower equipment is utilized to maintain the specified pressure differential. Manometer is utilized to monitor the pressure levels within the test chamber. Water is sprayed on the exterior face of the test area while simultaneously maintaining the pressure differential inside the chamber. This test is conducted for 15 minutes or the designated time frame. Staff observes the notes water observed on the interior side of the test area. Basically, it's recreating a storm. You're applying water to the outside with a pressurized chamber on the inside, and it's recreating basically a wind and rainstorm. Typically, you can get through 2 of a 64 square foot area in a day, again, depending on access and site coordination. The ASTM E783 air infiltration test, standard test method for field measurement of air leakage through installed exterior windows and doors. This is typically done at the same time as a water test. They test for the air and water basically in the same test because it's kind of set up the same way. A control blower is utilized to maintain the specified pressure differential. Manometer is used to monitor the pressure levels within the test chamber, and an airflow meter is utilized to monitor the airflow. A plastic sheet is taped to the outside, and a tear measurement is taken. The plastic sheeting is then removed, and the drop in pressure differential is then measured and calculated for the air leakage. Typically the same as the E1105. You can get through 2 of these areas, about 64 square feet. ASTM C1153 and ASTM C1060 infrared thermography. Standard practice for location of wet installation in roofing systems using infrared imaging. Standard practice for thermographic inspection of installation installs and envelope cavities of frame buildings. The ASTM C1153 infrared roof survey is the best conducted shortly after sunset when the surface temperature of the roof drops quickly. Areas containing water within the roof system insulation are cooled slower due to the water having a higher specific heat capacity than rubber roof membranes and most building products. Thermal analyses are found using the FLIR E60 thermal imaging camera. Typically, these areas are marked on the roof surface for future repair or evaluation. The ASTM C1060 can be utilized in very similar ways to locate thermal anomalies within wall systems, as you can see from the picture. Forensic water testing, standard guide for evaluating water leakage of building walls, voluntary guideline for forensic water penetration testing of fenestration products. This is your window performance evaluation, window to wall due diligence, sill dam tests, window isolation techniques, and you can perform the wrong test. Basically, this is trying to find leaks in existing fenestrations or newly installed fenestrations. And that's, you can see from the picture there that they basically blocked up the weep on the outside and they're filling the reservoir of the sill to see if the water joinery or the frame of the window joinery is leaking or if it's coming in from somewhere else.
You know, I'm sorry I had to jump back there and get on a train, so that test that John just talked about is one of the easiest ways to do QA. Anybody can do it. And what's most important about it, and I think the most challenging, I think John would agree, your windows are delivered, they're on a truck. You take off the first window, don't let the guy leave, still test it, make sure you accept the order. Once you accept that order of windows, it's over. And that's the challenge. You probably can expand on that, John, because of what you did for years. But once you buy that, once you accept that truck, it's over. So pulling off a window or two from the truck and doing the sill dam test is not a bad way to provide a little QA.
Yeah, and you know, and I've been on a job where, you know, we had 600 sliding glass doors that 50% of them leaked, basically from typical install, and it was just a poor design of how the sill was put together, and it was the jam in the sill didn't have a good connection, so there was a lot of remedial work that had to happen after the fact.
When you start talking to John about his experiences from being a window installer, it's kind of, sometimes it's a little bit overwhelming. He tells us stories about how windows are built backwards. The windows are put in backwards. There's all kinds of ways to do it wrong. And I guess talking to John about some of the experiences that he's seen from manufacturers, you're not always getting what you're supposed to be getting from the manufacturer, and you need to protect yourself. The architects need to protect themselves because they're, first time it leaks, they're calling you.
Yeah. And you know, manufacturers themselves are trying to get out windows as fast as possible. So sometimes your quality goes out the door. Samples, mockups, and prototypes. I think these are critical when you're specifying, you know, windows and putting in new windows. I think this is just kind of like your first go at it, that you get to, you know, put one in, see how it fits, whether it's good for the building, you know, the function. A lot of different things can be considered at a mock-up and prototype. So you have your involvement. That's the entire team. Your owner, your design professional, conservator, contractor, manufacturers, testing samples. You want to test the impact of adjacent surfaces, research and disposal, MSDS sheets, prototypes. Go ahead.
I'm sorry, John. No, I was going to mention, I saw in the comments somebody had mentioned MHT, or the trust determines certain outcomes of what to do with the windows. Mockups are a great way for historic structures to identify what can you expect, setting expectations, right? What's the aesthetic and what's the performance results of doing restoration to the windows. And the sooner you can do that, the better, honestly, to find out whether it's worth preserving or it's worth replacing. So I really do think mock-ups are always important, but they're even a whole nother level of importance if you're doing preservation and restoration to set expectations. You know, you never know. Some people want to see a brand new looking window from an old window. Some people want to see the chipped paint. being painted over. There's all kinds of things, and mock-ups are definitely the way to manage and control those expectations.
Absolutely. Highly recommend mockups. Building systems, fenestration, performance lab mockups. This is basically taking your mockup and sending it to a lab and having it tested for new products, evaluation, baseline performance. But there are many tests that Windows can go through. There's a list down at the bottom there, and these will provide ratings for, a lot of times the manufacturers already have ratings for their off-the-shelf type window, but when you start mulling things together and things that they don't make on a regular basis, some of that performance goes out the door, and you'll have to recertify or verify that the mold system is appropriate for your design. Prototypes, understanding the workflow and costs, photo documentation of the process, time track activities to get a better understanding of implementation and sequencing of labor, identification of and documentation of window damage, determination of your existing plumb and square of the rough opening that you're dealing with, and then your anchor design. What do you get the screw to? Did you take the old window out? Was it screwed somewhere where the new window can be screwed in? Identification of impact of handling hazardous materials, interior and exterior. This is lead, asbestos. That can be in caulking and glazing and paint. Identification and documentation of the impact of interior conditions. This is your drywall returns, sills, any type of special sills. That a new window, a lot of times old windows are deeper than new windows, so that you won't be able to fill the same hole the same way. Research and documentation of approximate repairs, quantities, and types required. And then identification of exterior trim and sill options. All of this can be done when you do your mock-up. This way you have a full understanding of what's entailed for the entire job.
I think one of the most riskiest things in the business is to be a window restoration contractor, especially for projects that are unquantified. I guess what I'm trying to explain, John, I know you and I worked on these together. If you're starting to have a contractor who's bidding lump sum jobs for window restoration, somebody's going to lose. Like somebody's going to lose. Either the contractor's going to lose, or the client's going to lose, or the consultant's going to lose. Somebody's going to lose. Window restoration jobs are very similar to concrete repair projects. They need to be quantified, and they need to have unit prices. That's the only real way to do these jobs. And I understand as architects, sometimes that might be too in the weeds, but I'm telling you, if you can set the table to make sure that the bid form has some ways to quantify repairs, you're going to get a better job. It might be a little bit more expensive when you bid the project, but you're not going to get the change orders, and nobody's going to get hurt. You might be able to expand on that more, John, but I just think it's really important as a takeaway that these jobs have too many unknowns just to give a lump sum number. It makes no sense.
I agree. And I think that prototype mock-up is your best opportunity to get the most defined scope possible. There's a lot of unknowns of how windows are put in originally, and then what comes out, what stays, especially in historic structures. There's a lot. The historic windows are kind of thick and bulky, and new windows are a lot thinner, and slimmer. So they don't actually fit, the same way as an old window does. Kind of like this picture that we're showing here on that bottom right. That's a wood window that would typically, the frame may stay in place and you would fit within the old wood frame with an insert or a new window with maybe new trim or cladding on the outside. So it's critical to understand, how does my window fit? You just can't call out a window to be replaced. Working through what stays, what goes, and a prototype mock-up will allow you to kind of get one of these under your belt so that the rest of the job will go smoothly.
I think sometimes this is where the wheels come off, because people look at a window like this and all these unknowns and unit prices, and then you think about just removing it and replacing it. It's not a wrong. It is a lot more simple, right? It just is, but I don't think it's always the right thing to do.
And it probably also does depend on each individual window too, that there may be some that are that require a lot more, surgery than some others. And I mean, so would you recommend doing sort of like a schedule type of way to kind of have an inventory of these types of windows and what exactly needs to happen at each location?
Yep. But just like, remember, if you saw before, we talked about doing a window survey.
Mm-hmm.
I mean, really, you should have a window schedule, even if it's a restoration project. In the window schedule, you can really get into those 3 different conditions, and that drives your scope, which will drive your lump sum or unit prices, and it drives the just a better approach to it. So you're spot on, and that's why it always is important to start with the window survey to really have a range of deterioration, and then from there you can identify a scope, go do a mock-up, and from the mock-up you really get a good idea of what kind of things are going to be known and what things are going to be unknown. And that's when you really start helping the contractor put an accurate educational number together, because then you can actually help him, parting bead repairs per lineal foot, glass each, like all these things you can really do and identify. Because if you don't, honestly, you wind up getting these numbers that are just all over the place. And it's it's difficult because all of us on the call probably are not developers, but those are the guys really kind of controlling and managing the costs. And I just think it's always good for us to give it a college try and see if they'll buy into identification of doing a survey and then creating these kind of mock-ups. It's a lot of steps. It really is. And I understand why sometimes it's just not enough time and money for it. But for a good project, do the survey, do the mock-ups, work towards a bid form with unit prices.
So this also kind of goes to one of the comments that we've received in the chat. It wasn't necessarily a question, but I do have a follow-up. The comment is that the historic tax credit reviewers at either MHT and NPS will be deciding whether the windows are salvageable. I think that in some of those instances, I think it is even more so important that each individual window location is being looked at, and that in some instance, I would imagine that you guys might be looking at it and say, okay, the windows are salvageable, but the sealants are not, or something like that, right? So there may be a different degree of like a little treatment that goes around each window. So that might be something that we all have to be aware of.
Yeah, and remember, we give the information to them to make a decision. So,
right.
Depending on the information you give is the result you're going to get sometimes. So I don't disagree with they have input, but I do think that there's good things you can do to put the windows in the right position to do whatever they're, whatever. To me, I'm a big believer, let the building tell you what it does. And to do that, you need to do testing and investigation. And the building will tell you what it needs. But if you just blatantly tell it what it's doing, then I just don't feel as good about it,
So there was another question that was sort of tangent to the discussion that we had about, I think, some of the energy modeling. I just wanted to kind of get to some of the questions. So there was a question about the different the energy modeling programs that you guys might be using to do any kind of analysis or any kind of studies as part of your report.
Now, the thing that we have in-house that we're doing is WUFI analysis, but I like to look at the overall building performance. So a lot of times we're kind of almost doing like an ASHRAE level 1. We're just trying to understand what's it cost to run the building, how's it working, and what can we do to improve the efficiency of the mechanical system in the building overall. So I think it's very similar to new construction. It's just couching it in the understanding of we're going to be limited. And really what we're looking for is not to hit a certain level, but seeing a certain amount of improvement, if that makes sense.
Right. Thank you.
Sealants are kind of the next step of the window replacement. Your sealant material selection, sealant joint design, whether it's liquid applied, pre-molded, cap beads, bridge joints, designing and sealant failure, whether it's a 3-sided adhesion, joint configuration, make sure backer rod is used, bond breaker tape, or a triangular backer rod. All of these are considerations and again, this kind of goes back to the prototypes, what that sealant joint looks like and how you can move forward with it.
Yeah, and since I've been a sealant guy for my entire career, whether I was a contractor or an engineering consultant, we really do leave sealants for the most part up to the guy in the field, honestly. no matter what you draw, they're going to do whatever they want. They don't really look what you're doing. You know, they do whatever works in the field. And there's some really basic fundamentals that they could be doing to improve a lot of the situations that they've run themselves into, and not creating two-sided adhesion and understanding bond legs, just understanding the science behind sealants. It's too difficult to think any of us can draw a drawing with literally the sealant design on it. It doesn't work that way. So I think having a crew that really understands all the different aspects of sealant joint technology is really important.
So your impact of interior finishes. Interior finishes need to be considered for both renewal and replacement projects. As I kind of talked about before, depending on how the window fits, where it will sit, whether you have to paint returns or repair returns, what are these returns made of? Is it a special material? Is it a special sill? I know in Florida, you know, they have marble sills all over the place. So is that on below the window, next to the window? Just some considerations. A lot of times, you know, windows have a long shelf life, so interiors are probably modified many times before the windows are even addressed. Hazardous impacts, material impacts, we kind of talked about this, asbestos and lead. Lead obviously is in paint. Asbestos you can find in glazing putty, sealants, popcorn ceilings. Industrial hygienists can be involved, and they can do testing of these materials. And this has a huge impact of moving forward with a full replacement or even repair for windows. If you have to go to abatement, that adds a lot of money to a job. Encapsulation is another way where you don't disturb it and you kind of leave it inside the building and encapsulate it with a material. So just things to consider as far as cost goes and impacts of the project. Project phasing. Is it exterior access? Is it exterior versus interior? A lot of guys like to put windows from the inside. At the company I worked at, we did 80% of our window installs from the inside. Is it a floor by floor approach? Is it an elevation by elevation? When you go floor by floor and you can do it from the inside, your mobility around the job is easier. When they go in drops, you're really subjected to the drop you're on. You don't get to move around the building. So just cost considerations, phasing, time.
Hey, John, talk to them about what you can and can't do from inside though, right? I mean, part of the issue that you and I always kind of had conversations was like, preservation is always vertical, window replacements is always horizontal. There is some cases where you really can't caulk from leaning outside the window. So
right.
You need to be really in front of it.
On, yeah, the window. You know, obviously you can't do that with a fixed window, or you can't do that with a casement window. So does your window itself lend its, you know, ability to be caulked from the inside? If you have a, you know, a single hung window, how does the guy reach the top? You know, because the top glass doesn't move. So considerations of what window are you putting in, and is it feasible to do it from the inside?
Yeah, it's a huge sequencing issue, really.
Absolutely, right. It does give you more mobility around the building because you can kind of work anywhere when you do it from the inside versus working off of a lift that's in a designated place for a designated time. So just kind of consider the phasing and access, and you know, and that can be guided. Renewal versus replacement. When does it make sense to renew the fenestrations? When historic requirements are there. Sustainability. Is it more economic? When does it make sense to replace the fenestrations? It's an owner preference, time, money, energy, all of these things, you know, the cost benefits of new windows versus old windows, a lot of things to consider for renewal versus replacement. How do you select a fenestration? There's tiers of manufacturers: high, medium, low quality. What material do you want? Is it aluminum, vinyl, fiberglass, wood, steel? And your ratings, commercial versus residential ratings. How high is your building? You know, the performance of the window, international and local code compliance, energy improvements, Energy Star ratings, performance, window selection, the AMA classification, desired wind load requirements, and new building code requirements. Or is it historic requirements? You have to get a replica approval. DC, you know, has a handful of windows that they've already approved as historic windows. You know, so the approval process is quick if you use one of those, but if you introduce a new product, then you'll have to go through a prototype and get this thing approved before you move forward with replacing the entire building.
You know, it's interesting. One of the things we get into recently is condo work, right? So repair work is covered by the condominium association. Replacement is covered by the owner. So sometimes these conversations are not easy conversations.
One of the frames, or one of the terms that window guys use all the time is called jumping the frame. And that basically means that you're getting rid of the guts of the window and leaving the frame in. And your new window is going to fit inside of the old frame and typically encapsulate the old frame within the system. When you jump the frame, some of the considerations is it's going to cut down on your daylight opening because you're going to have a frame inside of a frame. So that's something to consider, you know, when you think about jumping the frame, but sometimes jumping the frame has a benefit to if you have an abatement project, if you don't want to disturb the outside sealants, then a jumper frame would be an option. Typically in historic considerations, jumping the frame typically does not play into it. Here's our takeaway.
Hey John, can you mention something though about when it comes to like jumping the frame portion of this? I think one of the things you and I have been seeing recently is a significant number of jobs where people really think they can measure 4 or 5 windows on an existing window replacement job. And what does this jump in the frame do for plumb out of level and maybe inconsistent sized windows? Is there a pro or con to that?
So typically your individual windows are typically, they have been installed plumb and level. But you really do need to kind of touch a lot of windows to take a big sampling. If you get, you don't want sloppy windows in these holes. A jump the frame is actually probably more consistent than basing it on masonry openings, just because the window was ordered all at the same time. They were all made at the same time, but you really have to make sure that every floor is the same height. I've measured buildings where if it's a 10-story building, 9 out of the 10 stories are the same height, but the 10th floor is a different height. And if you've made an assumption, then you have a floor worth of building of windows that don't fit. So it's really important, that you take enough samples, to make sure that the windows are sized correctly.
Yeah, that was really my takeaway, John, because I think we're, at least recently, in the last couple of months, it seems to be almost every project we get into, we remove the trim, open it up, and man, oh man, there's just, because especially if the windows have been replaced before, then we have sheathing modifications. We find all kinds of stuff in a project where we're replacing windows for maybe the second or third time within the life of the building.
Yeah, and it really goes down to the experience of your measuring guy too. He's got to know. A lot of them are, if they're on the conservative side, then you're going to get a sloppy window in a large opening. They really need to know how to size the window and how it's going to fit. So these are our key takeaways, different types of fenestrations, how they affect the building envelope, factors to consider when evaluating historic fenestrations, factors considering evaluating fenestrations, leaks, establishing the process, understanding the different types of testing methods, mock-ups and prototype considerations, impact of hazardous materials, and evaluating the risk factors of renewal versus replacement programs.
John, real quick, one other thing I want you to talk to him about is flange windows and your experience up north recently on replacement windows and flange windows. I think it's a really important thing to share.
So when Mark mentions flange windows, there's 2 types of flanges. You have a center set flange, which is your nailing fin, which is typically used on new construction. It's a really excellent way for waterproofing a building. And in new construction, you're building a new building, so it's really easy to put those in. Not so easy to put a flange window into a renovation because typically people don't take down their facades in order to put a flange window in, but it is the best window to waterproof. There is a front flange window where it's the frame of the window and it has an extended flange that would typically be used in your jump frame applications where the old frame stays in place. This extended flange on the outside would cover up the old frame, and then you would use a clip and trim on the inside to kind of close it up. And then you have a non-flange window, and this is typical in your restoration jobs. You're dealing with an existing condition. There is no room for a flange, and you're going to have to use a flat frame and fit to the opening that you're been presented, which is typically, it couldn't be a jump, but it could be a rough opening or a masonry opening, whatever the building is made of.
Great, thank you so much, John. I do understand that it is 4:45 and it's just right about time, but if you do have any question, this would be a great time to just bring it up. And if you'd like to follow up with any additional questions, comments, feel free to reach out to KJ. That's, I think his email address is listed on the shared screen. Once again, before everybody leaves, if you have not submitted your AIA number yet, if you can send it to my email, or you can also send a direct message to me, that's fine too. If you could do that, that would be great. Any questions that you'd like to share with John or with the BEC's team?